Assalamu alaikum everyone, I'm Nadeem Shabir and today we'll be talking about primer designing. So to design the primers, we need to first get the sequence, the nucleotide sequence, and for that we access the National Center for Biotechnology Information website where all the gene sequences of any species are have been already deposited there. So we'll be accessing NCBI. NCBI is also a repository for certain papers, research literature. So herein we'll select the nucleotide sequence and we'll type in the gene for which we want to design the primers. Let's say, for example, we are interested in designing primers for ACE2, so of Homo sapiens. So ACE2 has been lately a lot in picture because it's said to be one of the receptors for the SARS coronavirus. And here we get these sequences of ACE2 and we can just select one of these sequences and design primers. So yeah, we have selected one sequence and it will lead us to its sequence information. So the internet is pretty slow here, but then yeah, it's how it is. Okay, here's the sequence, and if you can see right at the top left, you can see FASTA and GenBank, and we have to click FASTA, and there's the FASTA format of the genome. And just we can copy some sequence, maybe 300-400 base pairs, and use this for primer designing. Then for primer designing we use an online software which we call as Primer 3. So we just type in Primer 3 and here's the Primer 3 software. Okay, so you can see a box over here wherein we can just paste the sequence. You have to choose whether you have to pick the primer. Pick the left primer means the forward primer, and the right primer means the reverse primer. So we have certain parameters which we need to fill in. The first one is what's the product size that we want to amplify. So for a normal conventional PCR, let's keep the product size from 400 to 500. And there are certain criteria that we need to fulfill in here, and we have to make sure that the difference of the melting temperature between the forward and the reverse primer should not exceed more than 10 degrees Celsius. So I'll just keep it as 10. The primer GC content should not be less than 40% and should not be more than 60%. So that's the ideal optimal GC content we use. Then the two important things is self-complementarity and maximum 3' complementarity. So to start with, we always keep both the things at 0. We don't want a primer to have any 3' complementarity or even just self-complementarity. Yes, so the primer TM also we have adjusted it somewhere like between 55 and 62. It all depends on you, how stringent you want to put the conditions like. So you have to just do one thing and select primers, and here you can see a message that you are not able to get the primers. You have to go back and just keep on changing the stringency. So the stringency we are talking about is maximum 3' complementarity and maximum self-complementarity. Out of these two, we can compromise with the maximum self-complementarity but not with the maximum 3' complementarity. So we'll put maximum self-complementarity as 1, and still we did not get any primers. We'll go back and again change the maximum self-complementarity from 1 to 2, but still keep the 3' self-complementarity as 0. We'll again pick up primers. Okay, here we didn't get the primers. Go back and again kind of relax the conditions. We'll let the maximum self-complementarity be 3, but 3 prime is again 0. Okay, here we are able to get some primers, and if you can just see, I'm zooming in, so we do have some primers, and the base pair size is written there. You have the primer sequences here, so all you need to do is that the base pair size is like 477 base pairs. All you need to do is just copy these primers, and you can just order these primers as such. Okay, so that's it. So these are for just conventional PCR primers, but if we want to design primers for a real-time PCR, we need to understand and remember one thing, that when we are designing such primers, the primers should not exceed more than 150. The product size should not exceed more than 150 base pairs. So the ideal product size is 50 to 150 base pairs. So I'll set up the product size range from 50 to 150. Next thing is we want to keep the primer TM, increase the stringency, so we'll keep minimum as 58 degrees Celsius, optimum 59, and maximum is 60. So rest of the things will be same. So we'll start with 0 and 0, 0 self complementarity, 0 3 prime complementarity, and again we did not get any primer, so we'll set up this maximum complementarity as 1, and self complementarity, the 3 prime complementarity again as 0. We'll see we did not get the primers, go back again, relax the stringency, complementarity 2, 3 prime 0, again pick up the primers, we didn't find anything, go back again, relax the conditions, maybe the complementarity, increase it to 3, and 3 prime complementarity to 0, pick up the primers. Okay, it looks like the internet is a little slow. So these things are important. When we are talking about the complementarity, we can compromise with the self complementarity, but we cannot compromise with the 3 prime complementarity, and the reason for that is because the Taq polymerase usually attaches the primers at the 3 prime region of the primer and starts adding the nucleotides. Okay, at 3 we have got 3 0, that means 3 complementarity, self complementarity, and 0 self complement 0 3 prime complementarity. We did get primers, and so all we need to do is that once we have to check on these primers and then finally order the primers, we can copy from here and just check for rest of the things. So yeah, that's all from me. That's all about the primer designing things. So primer designing is very